Hello everyone, welcome back to ptet.chemistry channel. So in this lecture tutorial, I'll continue this year 9, 14 to 16 years old curriculum. This is year 9, the beginning of the 14 to 16 years old O-level or IGCSE curriculum. This is on the mole and the Avogadro constant concept. Question 3 is a lot trickier than the earlier questions because this is asking you on calcium and they want the same number of atoms. Okay, so they want the same number of atoms, 12 grams of magnesium. So we are given this, we are not given this. If I were you, I would start off by thinking about magnesium first. If I have the mole of magnesium, which is the mass over the AR, so by labeling this as mole of magnesium, small letter n, so representing mole, bracket the thing that I'm labeling, it means mole of magnesium. If you don't label n equal to m of AR, could be anything, and you do not want to leave your examiners ambiguous. You do not want to leave your response ambiguous, meaning uncertain and unclear. So the mole of magnesium is equal to the mass of the magnesium, mass in gram, divided by the relative atomic mass of magnesium. Straight from your periodic table, the AR is 24, so I could get 0.5 mole. Now they want the same number of atoms. Okay, so if I have this much mole, then therefore the number of magnesium atoms is going to be 0.5 mole multiplied by L. This is Avogadro constant. In Avogadro constant is the number of particles, in this case the atoms, per 1 mole. You only have 0.5 mole, so it's 0.5 times L. I'm not going to evaluate that because I'm going to use it to find out for calcium. Alright, so the number of calcium atoms is equal to 0.5 times L because it says same number of atoms as this much gram of magnesium, which was my answer here, and that is equal to the number of calcium atoms. That's what it says there, right? So on the left hand side, the number of calcium atoms, what can I say? Therefore, the mole of the calcium atoms, well, basically calcium exists as atoms, right? Because they're metals. So that thing there multiplied by L equal to 0.5 times L. So the mole of calcium equal to 0.5 mole. So hopefully you can see that now it's very clear. The mole of calcium equal to mass of the AR atom. Therefore, I use relative atomic mass. Calcium, because I have just now worked from magnesium, and then I use the concept same number of atoms. And I found out the mole of calcium, and the mole of calcium will be equal to the mass of calcium divided by the relative atomic mass of calcium. So I have 0.5 mole, which was my answer from the previous part, and now I want the mass of the calcium, and the relative atomic mass of calcium from your periodic table is 40. So the mass of calcium required is 0.5 times 40, because I can bring the 40 up there and it will be times 40, and that will give me 20 gram. So the mass ratio is not the same as mole ratio, and we work with mole because this is dealing with the number of atoms which are related to the Avogadro constant, and you could see that I did all this without even calculating the actual number of atoms by choosing to work with mole. Mole is a better one to work with unless you are specifically told to find the actual number of atoms or ions or whatever. Only then you evaluate it to give the actual number for the final step after you work through the mole. Let's continue. So I believe that is actually question 4, which means there should be question 5. And that's it really. Okay, so question 4, I have 3 moles of hydrogen gas. I hope you remember that hydrogen gas exists as H2 as part of your structure and bonding. Singly bonded hydrogen, that is not a dot and cross. This is the correct diagram for the dot and cross, where each hydrogen being a first period 1 elements, they can only fill up to 2 electrons in the first shell. Both the hydrogen atoms have a fully filled outer shell by sharing one of the electrons and forming a single covalent bond. So hydrogen gas exists as this molecule H2, but the question read it very carefully. A lot of the time it comes down to whether students can read or not. How many hydrogen atoms are there in 3 mole? They want the atoms and they want 3 moles. Okay, so what I could do is, if I look in H2, one H2 molecule has 2 hydrogen atoms. I mean, that should be easy to spot. There are 2 hydrogen atoms in 1 hydrogen molecule. If I have 3 mole of H2, that will give me 2 times the mole, or that will give me 2 mole, sorry. Sorry. One molecule will give you 2 hydrogen atoms. If I have 1 mole, that will give me 2 mole of H atoms. So if I have 3 moles, therefore 3 mole of H2. So I'm doing all this because I'm trying to go slow, but sometimes after you become an expert, you can skip some of this step and you can see straight away because you're thinking about this in your head. One hydrogen molecule has 2 hydrogen atoms. When you have 3 mole of these, you have 3 times 2, which is 6 mole of hydrogen atoms. So I'm writing all this down. Doesn't mean you have to write them all the thing down when you become more and more expert, but you really must know what is going on before you try to take the expert step, because in a real MCQ question, if you can't even read and interpret this information in your head, then you gotta write it down so they can see what's going on. All right, so now I have the mole of hydrogen atoms, so therefore the number of hydrogen atoms is going to be the mole, which is 6 mole, multiplied by Avogadro constant, which is 6L, so 6.02 times 10 to the 23 times by 6. That is the number of hydrogen atoms, not in 1 mole, but in 3 moles of hydrogen gas. So that's 3.612 times 10 to the 24 hydrogen, and this is not molecule, this is atoms. If they ask for mole of, well, the molecules, then 3 moles of hydrogen gas would be 3 moles of hydrogen molecule. 3 moles of hydrogen molecules. How many molecules are there? There will be 3 times Avogadro constant instead of 6 times that, because this 6 is for the atoms. On to the last question. It's part of these lecture tutorials into the idea of this using Avogadro constant and mass of Mr or mass of Ar. So we have this complicated looking aluminium sulfate, and this question is very tricky because it's asking how many ions. Okay, how many ions are there? By the way, if you look at this, there is 2 times Al3 plus, there is 3 times SO4 2 minus. Therefore, 1 Al2 SO4 3 has 2 plus 3, which is 5 ions. They did not say cation, they did not say anion, so therefore they say ions. Ions mean charged particle, so it could be cation, it could be anions, so cations and anions, because they did not specify. So altogether I have 2 cations and 3 anions, so one of these has 5 ions. If I have how many of it? I have 2 kilograms of it, so I can be thinking about the mole of Al2 SO4 3 times. So use bracket and label very carefully. I should really work out the molecular mass first of all, actually. So perhaps instead of mole, I just work out the Mr. So straight to the periodic table. So let me see my periodic table. So aluminium is 27. So multiply by 2 because I have 2 aluminium. I have 3 of this whole unit, so I will have plus 3, big bracket. Inside the bracket I have 1 sulfur, which is 32 times 1 or 1 times 32, doesn't matter. I have 4 oxygen, so 4 times 16 or 16 times 4. Put that into a calculator, be very careful with this. I would do the 32 times 1 plus 16 times 4 first, then times by 3. And then I get 288 plus 27 times 2. I get 342. Remember the Mr has a unit of gram per mole, because what we're going to do next is the mole. The mole of aluminium sulfate is going to be mass over Mr. I have 2 kilograms, so there's 2.0 times 1000. This is gram divided by the molar mass, which is gram per mole, and that will give us the mole of aluminium sulfate. Okay, so there's 2.0 times 1000 to convert kilogram to gram, divided by 342. I get 5.848 to 3 decimal place so far. This is mole. So this is the mole of aluminium sulfate. Now going back to what I have said, one of these has 5 ions, and you want to know how many ions there are. So therefore, the actual, or you can say the number of ions you have. Actually, before I do number, perhaps I can do mole. How many mole? How many mole of ions I will have? One of these will have 5 ions. If I have this much mole, I will have 5 times this much mole. There will be 5 times 5.848. This will be the mole of ions. How many mole of ions do I have? I will get 29.24 mole of ions. This is of Al2SO43 units. This is the mole. This is mole, but I want the actual number. I want the number of ions. So therefore, the number of ions is equal to Avogadro constant, which is 6.02 times 10 to the 23, multiplied by the mole of the ions, which is 29.24 mole. 29.24 times 6.02 times 10 to the 23. I get 1.76 times 10 to the 25 ions. This is the total number of ions because there are 5 ions. Question could change to how many cations there are. Since there are 2 cations, so instead of 5, I'll have 2 times these times Avogadro constant. That will give me the mole of cations. How many anions, or how many negatively charged ions do I have? I have 3 mole of SO42 minus from 1 mole of these. So I'll have 3 times that times Avogadro constant to give me the number of anions. The number of cations plus the number of anions give me the actual total number of ions. So I do not have to do them separately. I just said there are 5 ions. That was why I did, and that was why I had 5 times the actual mole of that aluminium sulfate before I multiplied further by Avogadro constant to get the total number of ions. Alright, so that's it for this lecture tutorials. I've basically talked about mole equal to mass over mR or mole equal to mass over AR. I have also talked about this idea of using Avogadro constants and relating Avogadro constant with the number of mole of the particles, whether it's atoms or ions or cations or anions or molecules, with the actual number of particles that are present. A lot of these things relationship is to do with having one unknown. Usually it's the mole, but sometimes you could be given the mole or the 2 of the out of the 3, and you're asked to find one that is unknown. Not necessarily this one, it could be this one where you rearrange it, or it could be this one at the bottom where you move this up and the mole comes down. Same thing for this, not necessarily always finding this. If you have this, if you know Avogadro constant, you can work out the number of mole, because the number of mole is equal to number of particles over Avogadro constant, because in 1 mole you have this much particles, so the actual number of particles divided by Avogadro constant, you're going to get the number of mole based on this relationship. Alright, so that's it for these lecture tutorials, and I'll see you in the next lecture tutorials. Perhaps you can go through some of the other tutorials on the work itself, the associated work related to this particular lesson, and then you will see how the concepts are further exemplified with questions, all right, in real life examples, basically from past paper questions or from various other sources. Thank you for watching, and don't forget to click the button on the bottom right to subscribe to the channel, and share the channel widely with all your friends, chat group, juniors, seniors from school, and other people, and follow me at ptet.chemistry. That is ptet.chemistry on Facebook, Instagram, and Twitter.